Welcome to Mathlink, where we connect the dots. I am Mr. C, and I'm excited about this particular subject that we're going to talk about in algebra. We're going to talk about how do we get rid of parentheses and also combine operations. So we can combine adding, subtracting, multiplying, maybe possibly dividing, how we combine all these operations in algebra expression. So let's get started. So sometimes the best way to do and to understand how to do algebraic expressions and simplify them is just to do it. Hopefully you had the opportunity to look at some of my past videos to understand where we're at right now when we're talking about getting rid of parentheses and also combining operations. So please look at my past videos with algebra expressions, with adding, subtracting, multiplying, dividing, and also with powers. This will help you with this particular unit that we're talking about. So let's jump right into this. So we have two expressions pretty much, and we want to get rid of the parentheses. How are we going to do that? So we have 7x plus this other expression. Remember, I put in parentheses. Now, since it's a plus, I basically can do this. Like we rewrite this and say, this is equal to 7x plus a negative 4x plus 3y minus 2. Basically, I could say that because this plus means nothing changed inside the parentheses. Now, if this particular plus in front was a negative, let's say that plus was a negative, then all the expressions would have been opposite signs of each other once I got rid of the parentheses. But it's not, so we're going to leave it like that. So now the next thing we're going to do is we're going to look and see if we have any like terms. In this case, we do have like terms. I'm going to underline the like terms, which is 7x minus 4y. We know they're like terms because we look at the letters. Now, once we have that, we combine the coefficients, which should give us, in this case, 3x, and then we say plus 3y minus 2. Okay. And then that's our final answer because we cannot combine any other terms because there's no other like terms. Okay. Now let's go a little more advanced and look at another problem, removing the parentheses. Now this problem, let's jump right into it, how we remove the parentheses. Since we have a negative number or negative sign in front of these parentheses, I'm to get rid of those parentheses. I'm going to distribute that negative sign to everything inside just those parentheses. So let's do that and see if you can see what I'm doing here. So to get rid of the first set of parentheses, it'll be a minus 7a squared minus b plus 3. Because of that minus sign, it changed all of the signs inside the parentheses opposite to each other. Now, we have a plus 12. That's not in parentheses. That's okay. Now, let's look at this here. So we're going to distribute this minus sign here and here. So this gives me a plus b and a minus 5. And so that's how we got rid of our parentheses for our expression. Now the next thing is to see, are there any like terms? So in this case, we got a squared, we got minus b plus 3. Well, we do have a like term here, and I'm going to underline it. We have plus 3 and 12, we can do that. And we also could do the 5. And you say, hey, Mr. C, I see something else as a like term. I see a b here and a b here, a minus b here. So there we go. So let's try this particular problem with what we have. So we got a negative 7a squared. Now notice that we got a minus b, but we're underlining in red because they're like terms, and a plus b. So that cancel. So that's gone. Plus and minus the same term will become a 0. Now we have 3 plus 12, which is in green, which is 15, minus 5, which is 10. positive 10, and that's my final answer for that particular problem. Again, let's look about removing the parentheses, looking at other types of problems. I'm giving you all a variety of types of math problems of how to remove the parentheses. Now for this one, we have 5b, nothing wrong with 5b. So let's just write that down, 5b plus, that's good to have that plus. Now we have 4b times this expression that has 3 terms. So what do you think we're going to do with that 4b to multiply times that expression? That's right. We're actually going to distribute from here, here, and here with our 4b. So go ahead and do that. Let's do that together. So for this problem, it'll be 4b times 5, which is 20b. 4b plus a would be plus 4ab, and 4b minus 2b squared, 2b, will be a minus 8b cubed. Don't forget that b has a visible 1 in front with that 4b over there. Now let's see if there are any like terms here. Oh, I just actually see something. We do have a like term. If I did this correctly, we have a 5b plus a 20b. In that case, that's, I think, our only like term that we have here. This would be 25b plus 4ab minus 8b cubed. And that's my final answer because there's no other like terms to add and subtract. Again, we add and subtract with those like terms. That's adding, subtracting like terms, not multiplying, but adding, subtracting. Now let's look at one more problem in particular. I wrote it out for us on our whiteboard, and let's get rid of the parentheses and simplify. So for the first problem, we have 3a, and we're going to multiply that to everything inside the parentheses. That's called a distributive property. And do the same thing with the 5. Multiply by everything inside the parentheses. That gets rid of our parentheses. So let's do this. Okay. So for 3a times 4b, that gives me 12ab. And then the 3a times the 2a will gives us plus 6a squared. Again, same base, you multiply with the same base, you add the exponents. Don't forget there are ones on top. You can't see them with the a and a. Now let's do the next one. Plus 5 times 2a, which is 10a, and then 5 times the negative 3b squared, or minus 3b squared, be a minus 15b squared. Now, let's see if are there any like terms here. Since we're adding and subtracting, you think about like terms. ab, a squared, a b squared. Ooh, doesn't look like we have any like terms if I did it correctly. Therefore, that's my answer right there. Again, I hope this helped. And again, review this video again as many times as you can, and also look at our supplementary resources on our Mathlink website. Again, let Mathlink bring it together.